forgot the rope. So does this thing work here? Okay, hi. I'm Max. I'm writing text editors for Mac and iOS and run a company called the Seelemann. Here's a picture of our main app, Ulysses, on the Mac. It's a writing app, just so you know what I do. All right. So the title of this talk is TextKit for the rest of us. Here's a little thing I have to share. There is no short introduction to TextKit, unfortunately, but we'll do one anyway. Okay. What is TextKit all about? To give you the very first idea, see, this is text on an iOS device, in this case an iPhone, and you may find it ugly. It's code, and it does not look like you would want your code to look. So what you do is you want something that is nicely formatted, has syntax highlighting, has paragraph numbers, and stuff like that, and TextKit makes the left into the right. That is TextKit. Nothing more and nothing less. So, and we will start out with little history on the architecture of TextKit and all the pain you had to go through in earlier releases before iOS 7. And then I'll show you how you do syntax highlighting, and we probably make it around to showing you how to add paragraph numbers. There will be a demo project up on GitHub that you can investigate later on where there's more in, but we'll just get to talk about two things here. All right, so architecture, history, the history of pain. So let's say you want to build a text editor. You have a user, obviously, who's in front of the device, and he wants to edit some text. So you need classes to represent this. And the text is obviously the model, and the user is obviously on the intersection with the view. And the view is, you may already know it, UI text view. It has been around since the very first SDK in iOS 2. And in iOS 2, it allowed you to store text in NSString. If you know NSString, it's a very simple string class. It just contains text. There is no formatting. There's nothing special about text other than being text. And that's it. You would expect where there's a view and there's a model, there should be a controller, not on iOS 2. There was no controller layer that was publicly available. So all you were able to do is have a text input. For those of you who were around at iOS 2 times, it was the time when there was no text selection and no copy and paste. You might remember that. So quite time ago. All right. So there's no controller, but at least in iOS 3.2, when Apple introduced the iPad, they did a little improvement. They made an API that allowed you to capture the keyboard input, and UI text view was using that. And they also gave you a text rendering and layout API called Core Text. And they also introduced a string class that allowed you to store attributes like fonts and colors and everything you would need for a code editor. However, this looks nice. You might assume that UI text view would now be able to do attributed text with colors and fonts. But there is a red line. And there is no connection between the left side of the red line and the right side of the red line. So UI text view was still just doing NSString. And if you were wanting to do anything special with text, you would have to resort to Core Text, which is a C API, and use the attributed string. You would have to do your custom view implementation if you wanted a text editor to build with attributed strings or colors or something, and you would have probably to implement your custom layout. These green boxes are what you would have to do on your very own, and it's like, for an experienced text developer, I would say I am one, I would have assumed like 4 or 5 months of work. So nothing done easily. You would have to do all on your own, like text selection, like painting the blue blue handles and stuff like that, and handling all the 10 different gestures you can do, you would have to do this all on your own. So. All right, so we don't want to do this. So let's wait. iOS 4 comes around and nothing changes. iOS 5 comes around and nothing changes. And you're thinking about, maybe I should, but then iOS 6 comes around and there's a change. UI text view in iOS 6 is able to use NS attributed string. However, that's it. So you're reading through these changes and say, hey, UI text view does attributed strings, it does fonts and colors. We still can't do a text editor. You would still have to do all it on your own. So iOS 6. Skipping 1 year, there is now iOS 7, which is the current state of the art, and Apple introduced the all-new TextKit framework and introducing 3 main classes: NS text storage, which is just an NS attributed string with a little detail added, but other than that, it's just a string. And then they have 2 classes: layout manager and text container. It is a model view controller hierarchy or class structure, or how you call it. And like I said before, the text storage, well, it's the model. It should store the content, which is text, so the text storage stores the text. The layout manager obviously controls the layout. It does all the layout. We'll get into that in a moment. The text container defines where the area is, where the text should go, what the shape of the text should be when it's printed out. And the UI text view is merely a display port and handles the user input. So all the magic of how the text is being rendered and laid out and colors and everything is handled below UI text view. UI text view is just like a canvas you would paint on, nothing more other than handling input. Okay. So with iOS 7, you can do this stack on your own. You can just drop in a text component from Interface Builder and in your storyboard, or you can build it on your own in code, which is very, very simple. All you do is you create a text storage by calling NS text storage new. Then you create a layout manager with NS layout manager new, and you add the layout manager to the text storage. Then you create a text container and add the text container to the layout manager. And then you create a text view and init it with the text container. That's it. So, like, it's 4, 5, 6 lines of code you would have to write to build a custom text component in iOS 7. That's a very basic, simple setup. And you can then go ahead and replace each of those components with a custom class and your adjustments you made. One thing to notice is I draw these black arrows here. You have to retain both the UI text view and the text storage. Just if you ever come to build your own, that's one thing to remember. Otherwise, you won't see any text and wonder where it's gone. All right, so that's it for the basic architecture. Let's get into the real shit. Syntax highlighting. We are programmers, aren't we? Code. Code has to be colorful because otherwise we won't be able to read it. And so the very most important feature every programmer needs is syntax highlighting. I've written a very simple example syntax detection that does recognize comments, pragmas, and a set of the 3, 4 keywords that are in this example. So, but just so you know, green is comments, brown is pragmas, and pink is keywords. So that's what we're going to do now. All right. So we look at our stack again. We have the model, view, controller. Well, the view, the UI text view, is for display and input. It's obviously nothing I would do color computation in. The NS text container defines where the text should go. That does not sound like color coding. And controlling the layout does also not sound like I should assign colors. What leaves to us NS text storage. It stores the text, and what I didn't tell you, it also stores the attributes, which is the colors and the fonts. So this is the place to go, NS Text Storage. We create our custom class, TKE Text Storage, we subclass NS Text Storage, and we're good to go. Almost. You know class clusters? I hope so. If not, class clusters means that the NS Text Storage class is abstract. So whenever you just call NS Text Storage alloc init, you get a private Apple internal subclass that you may use. And when you're trying to write your own subclass, like we are now at TKE Text Storage, what you have to do is you have to implement a certain set of methods. For NS Text Storage, that is 4. We'll go through them. It's 4 very, very simple methods. And the common approach to implement a very simple class cluster subclass is to start with a composite object, how you call it. So you would take one object from Apple that they already did. They did all the work, and what you would do is you would just instantiate it and forward all the calls. So I'm not using NS Text Storage here because we don't need it. NS attributed string is about exactly the same, just like I said, so we're using NS attributed string as storage. So, simple text storage as composite object, you write 5 methods. More is not needed. The first is init, where you instantiate your NS mutable attributed string, which you use as your composite object slave. And then you implement the string getter method, which returns the string of the slave storage method, storage object. And then you implement the attributes at index, which returns the font colors, the fonts, the alignment, and stuff like that. But you just forward it to the other object. And then you have to implement, these are the 2 getters, and then you have to implement 2 setters, which is replace characters in range with string, where you say, hey, take this text and throw it away and put in new text. And what you do is you just forward it to the slave. And then you say, implement set attributes for a range, and what you do is you just forward it to your slave. And it all works. There's one little detail you have to pay attention to, because NS Text Storage is a little bit more than NS attributed string. So all the difference that is there comes now. You need to send a notification about every change you do. So you have to call a method called edited range change in length. And you send NS Text Storage edited characters, which tells the text system that there has been a character range, and you say which change was happening, which range you replaced, and what is the change in length of text that you applied. And from this call, all the stack will be updated, everything will be re-rendered, everything will happen nicely for you. You don't need to do much. All you need to do is just send this notification, and do the same for set attributes, where you just call, hey, I changed the attributes in this range, and no change in length. All right. So we have a custom text storage in our demo app, and what do we end up with? That's not what we want. It's just the stock text component. We wanted to do syntax highlighting. Okay, because we didn't do any syntax highlighting code yet. That was all just getting us into the right position of being able to do syntax highlighting. But now we are, I promise. So this was what we want. I propose a slight change from the simple composite object. Just experience what we have done in our apps, and which seems to work quite well, is the composite object where you still have a storage, but you take like a smart object storage, like an AST you've parsed from your C compiler, or you take anything you have, like a database record where you get stuff out and don't know. But in this case, we just have a smart string, a string that is just a regular string but knows about code, which I said is very, very simple, very, very straightforward. And this code string does not have any attributes. It's just a pure string that knows some of the semantics stored in it. And it holds the text or the code. And then we build a cache from it, where we take the string and take its characters and then apply the colors in there. The beauty of this pattern is that the model, so the code itself and the knowledge about the code is separate from the colors you apply to the code, which just makes a good architecture. This is something I proposed and which I did in this demo, so that's why you have to go through it. All right. All you do is, when you replace characters in range, you just forward them to your cache, and you forward them to your storage, which is the code string. That's it. So the code string knows all about the text. And then when you change the attributes, you obviously don't forward it to the code string because the code string does not have attributes. You just forward it to your cache. All right, so we now have a cache of the code, and we have a code string that knows all about the code, but we still don't have colors. And here is where is the right spot to compute the colors, and I will have to go a little detour to explain you how NS text storage works internally, how modifications are made, so you understand where's the best place. So whenever a user comes and hits the A button or the bracket or something on your keyboard, then the text storage gets sent a begin editing message, which just tells you, hey, we will change something. Then there will be called change methods like replace characters in range, and after that change, there will be called end editing, which says, hey, we're finished with editing. And when the editing is done, the change notification will be sent out. So, yeah, right, and we'll do all the updating. And within this three-step thing, we call our implementation, we just forward it to our cache, like I said before, like you saw, we just forward to our cache. And in the end editing, there's a method being called that is called process editing. After every change, after the time, the point in time where every text has changed, you get a call that tells you, hey, I have changed this part of the text, which is the method process editing. And just in there, you compute the colors. So it's very sweet spot, and no many cases you have to handle. It's very, very straightforward. You just know where you're going. And in this compute colors, what you do is you ask your smart code string. Like I said, I won't show it to you because it's ridiculously simple. You just ask your implementation, your backing, your storage. In my case, it's a code string, but it could be your AST. You could say, please iterate over the range that has been changed. And then the string gives you a callback, a block that tells you, hey, this part is a comment, this part is a pragma, this part is a keyword. And then the text storage maps the colors. It takes the knowledge about the type, the TKE code type, which is just pragma, comment, and constant, and it turns it into a color and applies the color on the text. So that's it. So all the code we actually had to write was just this one method. That was the interesting part. These like 4 or 5 lines of code we had to write, but all the stuff we did before was just getting us there and being able to do the change. Right. So we have syntax highlighting in our demo. Hey. I'll give you a live tour in a moment, so you will see it works. The other thing I wanted to talk about is paragraph numbers. I've chosen paragraph numbers because it gives you a little glimpse over the other classes that are in TextKit. Obviously, we won't be able to cover everything you can do, but here's one more shot. So again, our picture of our code editor. You can see paragraph numbers if you don't know what. There's the red rectangle. These are the paragraph numbers. They denote which paragraph is at which line. On the right side, on the right side, the blue rect is the text that you have. And what you can see from this picture, I'll hide it, is the green frame, the outer frame, is the view itself. It's the text view. And inside this text view, we now want to put paragraph numbers, which are on the left in our case. So this means we have to reduce the size of the area where the text can be drawn, which is the blue rect. Before, it used to be all just text, but now we need space for our paragraph numbers, so we need to make space. Okay, let's look. Where could we possibly go if we wanted to have some space around our text? Okay, display and input, it obviously isn't. It obviously also isn't text storage, because like where the text goes does not belong into the storage. It also not in the control layout part, because it does not control, but define text area sounds quite right. So we'll go and look at the NSTextContainer. NSTextContainer is a very, very, very simple class. It consists of a single method that is being called quite often, but it's just a single method. And it defines the text area. So usually you have like a rectangle where you say, hey, this is my rectangular view, and I put my text in there. And, but you may have anything else, like you may have a circle where the text goes in, or a concave shape, or you have holes in your text where the text should flow around. This is the duty of NSTextContainer, to tell the text system. And it works through a single API, like I said, this elegant method. Line fragment rect for proposed rect at index writing direction remaining rect. I'll give you a second. But if you look at it, it's also, if you know where you're going and what you're supposed to be doing, it's quite straightforward. It just could be confusing at first sight. So say you want to implement a text container that describes a rectangular text area with a hole in it. And this goes only through a single API. How does it work? So the API will be called with a proposed rect, which is be given to you like this one, the red one. It proposes you, hey, I know how wide you are. Here is a proposed rect for one line. And then you are told where it is and what direction you're going in, and you're asked to return a rect that is to be used as the line. So in this case, it's very simple. It's all good. Yeah, the line should be there like it was proposed, so we just return the proposed rect. In the next line, so we finish with one line, then we will be called again for the next line, and the next line will be proposed the same rect. But obviously, as you can see, we would now hover over our circle, and what we do then is we return a shortened rect. It would say, hey, you proposed me this big rect, but just this small part is allowed for you to fill with text. And then from the last parameter, the remaining rect out parameter, you return the rest of the line. And the rest of the line will be queried again through the very same method. You will be proposed this rect, and it's okay, so you return it. And then it continues, like line after line. Every line will be queried, and you return a different rect. So this is how text container works. If we now wanted to inset the text container, we go ahead and just take the original coordinates that are returned from the default implementation and just make it a little smaller and offset it to the right. Would be great, wouldn't it? If only this was not a bug. So what you're able in NSTextContainer is you are allowed to shorten the line, but you're not allowed to offset every line like 5 or 1 pixel even. You're not allowed to. It will hang the text layout. So you have to fiddle your way around, and you end up looking at your stack again and wondering, oh shit, where should I do? What should I do? I can only make lines shorter, but I want to offset them as well. What an incredible thing to do. All right, so here is the thing. I lied to you. The NS Layout Manager does not control the layout. It's merely a store for the layout. So then is the question, if the layout manager only stores the layout, who controls the layout? Well, there's 2 more classes I didn't show you. There's NS Glyph Generator and NS Typesetter, which are the 2 that create the layout. So, and the flow is more like that. So the text is taken from the text storage by the glyph generator. For you it's the other direction. By the glyph generator, it's converted into glyphs. We'll get into that in a second. And then the glyphs are placed inside the line rectangles that are returned from the text container. And then once the layout is computed, it's stored inside the layout manager. and then only rendered into UI text view. So I lied to you for a reason. Oh, there's text layout manager delegate, yeah, as well. You can do stuff in there. The reason is NS Typesetter and NS Glyph Generator are private on iOS. They are available on macOS. They are the logical place to go when you want to manipulate the typesetting behavior, like NS Typesetter would be the right place to go if you want to indent lines and draw them like whatever you want. But these are private. So what happens is you have to spread your code. You have to spread your code across NS Text Container, NS Layout Manager, NS Text Storage, and NS Layout Manager Delegate. So everything is still possible, only that you have just, instead of having it in one class, you have it now in 4 classes. All right, so let's look at the, so we stick with the NS Layout Manager controls layout stuff. I did not lie, actually. Maybe not. So okay, let's look at typesetting, how it works. You have the view where the text area is described by the UI text container. Like I said before, it's the thing with the lines and the rectangles. And then you have the text in NS Text Storage. And what you want to do is you want to take the text from the text storage and place it inside the view, obviously. And the thing is to be computed, and then the result is to be stored in the Layout Manager. And we know it's done by the NS Typesetter, but you must not know. We do know, but you must not. All right, so what we do is, the first thing we do is we ask the text container, please give us a line fragment rect. The text container is a nice guy, and he returns us a line fragment rect. And then we ask the glyph generator to give us a glyph for a character. The glyph is like a picture. Just imagine a font like Helvetica or Arial or Comic Sans MS to be just a map from character like A to a picture of the character A. And in this case, here is, I think it's Sapfino or something like that. The glyph generation is just a translation from characters to glyphs, to images. And with these images and the text attributes, which is colors and offsets and stuff, link attributes and stuff like that, then the line is being filled piece by piece with so-called runs. Not so important, but the line is being filled piece by piece by the typesetter, and once the layout is done computing, it is being stored in the Layout Manager. All right, so now that we understand typesetting, how does it help? We know that we can shorten the line in the UI text container. That's what we did already. Where do we offset the line? We offset the line at the point where it's being saved. This is a hack, obviously, but it works. Nobody complains about it. It works since a couple of years, so the bug is in there since forever, so, and it's been on macOS as well, so don't wait for it to be fixed. And you offset the line at the point where the line is being stored. Now that we know where we need to go, which is the important part I'm trying to tell you, is we just override set line fragment rect for glyph range, and the passed in rect we offset by our inset that we want. There are 2 rects being passed in here. That's not important. You just offset both for now. You just have the same rect again with the little different semantics, but it's not important for now. So what you do is you just take the rect and offset it. You shorten it in the text container like we showed before, and then in the Layout Manager you offset it. And then what you get is offset text. All right, and we're almost done. Drawing the paragraph numbers is also very simple, very, very straightforward. You only need to know where to go. I'll tell you. There's a method called draw background for glyph range at point in NS Layout Manager, which you override. You just call the super implementation. It does all the stuff for you. And then you iterate over all the lines that are you should be drawing, and ask the Layout Manager for the line fragment rect, so the rectangle for the line you're in, and so then you just call your draw methods like NSString draw in rect, and that's it. So the drawing is very, very straightforward. You only need to know where to go and how to iterate over the lines, which is shown there. All right, and then we have paragraph numbers. So I can give you a short demo. We're running low on time, so I'll have to do it quick. But I still want to show you it works. So you should be able to see. Yeah, all right. So you can go in there and type text. And if you type a word, it's gray. And if you type int, it's getting pink, like you would want to. The comment is not being green because the recognition is so simple. So it's a live editor, and you can do stuff, yeah, like you would expect. There's nothing more to it. The paragraph numbers do work, obviously. So if I delete it here, then you see how it rewraps, and the paragraph numbers are moved over. All right. So this is the picture I want you to remember. Remember the stack. Remember the layers. Remember which part does what and where to go. This is the important lesson. Know where to go. Once you know where you have to go and what you have to do, it's very simple and very straightforward. But learning where to go takes the time. This is why I've put up this demo project on GitHub. This is the URL. In this demo project, there are more things to see, like indented line wrapping, so that the line wrapping does not start at the very front, but wraps by the brackets or by certain indentation. And dynamic line height and dynamic tab size, because you want tabs to be equal size, like 4 spaces. So that's it. Thank you.